Okay, so here is a demonstration of the use of an independent t-test to test for differences between groups. So this research hypothesis is that the 5K PB times of men and women are not the same. The first four assumptions would have been dealt with in the study design, and they are that the dependent variable, which is 5K PB, is measured on a continuous scale, and it is, which is time. That the independent variable is categorical independent groups, which they are because we've got male and female. That the observations are independent and the samples are representative of the population. The next three assumptions will be tested for an SPSS. They are that there's a normal distribution, there's homogeneity of variances, and there are no significant outliers. So the null hypothesis that I'm testing is that there is no statistically significant difference in the 5K PB times of men and women. So my data was collected in Excel, so I'm just navigating and opening that up now. See, we've got ticked the read variable names from the first row of data, and it also tells you what the worksheet is. So the first thing that we do is check that we're happy with our data, and we'd also go into variable view to check that it's recognised it correctly as the type of data, i.e. scale or ratio. But because of time, I won't demonstrate that, and I'll hit straight on to our testing for normality, which we're going to do using frequencies. So we're going to place the 5K PB time into our variable. And then from statistics, we're just going to limit that at this stage simply to skewness. And we're also going to demonstrate the distribution of the data by using a histogram. And we want to see how our data compares to the normal curve. So I'm going to check this box here. Okay, so that will compute. So in the statistics box, this shows us here that our measure of skewness is 0.66. Now for skew, anything, a value that is between -1 and +1 is okay. So that would indicate that yes, our data is normally distributed and and this test is appropriate. We're just going to go down and have a look at what our histogram actually looks like. So here we can see that the data is distributed within that normal curve. So then for the actual test itself, we go to the Analyze menu. We choose Compare Means and then Independent Sample t-tests. Okay. So gender, which is already selected, is the grouping variable. So I'm going to put that in there, and I'm also going to let it know which groups I want. So on the spreadsheet, the names of the groups were male and female. So that is what I'm typing in here. And then 5K PB, that is my test variable. So I'm going to load that into there, and then I'm going to go OK. And Excel will run the test for me. So this first table is the descriptive variables, and it's the second table which is of interest to us. So I mentioned earlier on about this homogeneity of variance, and what that is it's testing the assumption that the variance within the samples is the same, so that the variance of the males is equal to the variance within the females. And I can see that from this significance value here. So we set a p-value at 0.05. This significance here is greater than a 0.05. Therefore, the variability is about the same, and we know that we can take our readings from now on from this top row of data. Our t-value is minus 1.107, and that's the critical. That's what we'd use to compare with the critical value if we were doing this by hand. What we're interested in is this significant two-tailed value, and as this is 0.271, this is much greater than our test value of 0.05. Therefore, there's no statistically significant difference, and we haven't been able to reject our null hypothesis. So the final outcome that we have, T at 98 degrees of freedom equals minus 1.107 at a p-value of 0.271, which is greater than 0.05. So we fail to reject a null hypothesis, and there is no statistically significant difference between the PB times of the two groups.